if any one of the above steps fails, the TLS handshake will fail, okay, and the connection will never be created, right. Right. How do you do that? I mean, this is that you are looking into a path, then you have to somebody has to give a blindfold to your eyes. It is not possible. So, you can see maybe here what we can think is that eavesdropping means you can see, but you cannot make out any meaningful from it. That is what is meant basically. So, now the handshake in details, handshake protocol. The TLS protocol exchanges records which encapsulate the data to be exchanged. So, in the first introductory slide we mentioned cipher suite, records, handshake, change cipher spec, etc. Okay. So, basically this handshake protocol will use exchanges records which encapsulate the data to be exchanged, and on this data in the record you can have these operations: compression, padding, appending with MAC, all like this, one upon other, or encrypted, all depending on the state of the connection. Okay. I mean, so you may have all these operations on the data, or you may have some of them like that. Each record has a content type field that specifies the record, a length field and a TLS version field. Okay. So, the record, apart from the part where all these operations have taken place, it also has a content type and a TLS version and a length field. That means, how much to expect, how many bytes to expect, whether they will be fragmented and come in sub packets, that must be there. When the connection starts, the record encapsulates another protocol, okay, the handshake messaging protocol, which has a content type 22. So, that means, if it is the data for handshaking, it is also a record, but here the data is for handshaking. So, the content type, that means what type of record it is fixed. So, the fixed number is 22. If 22 is mentioned, then either the client or the server understands that the data that is following is actually data for say handshaking. That means, maybe the choice of algorithms, choice of keys, like that. Okay. Otherwise, the content type may be something different, which will let know that this is the actual payload or something or the other. Then starts the negotiation phase. The client sends the client hello message specifying the highest TLS protocol version it supports. I mean, the client may support anything, and if you mention the highest, that means it can support the lower versions also. A random number, okay, a list of suggested cipher suites and suggested compression methods also, because ultimately the data will be provided compression. Here the operations you see, each record can be compressed, padded, appended. So, compression algorithms are also required. Okay. The server responds with a server hello message. So, you see the client always starts the phase. Okay. The client discovers that it has to get some service from a such and such server. So, it starts establishing a connection with that server. Hence, the client will be the first one to send the hello message. Okay. The server responds with a server hello message containing the chosen protocol version. a random number, some other random number, cipher suit and the compression method, and obviously all of these will be from the list offered by the client, okay? Because otherwise how do you agree upon a common methodology? The server may also send a session ID, okay, as part of the message to perform a resumed handshake. The server sends its certificate message also, which is optional, indicating, and the server sends ultimately a server hello done, indicating it is done with the handshake negotiation, and then the client will respond with the client key exchange. I mean, the server may be done, but the client is continuing, it is not yet completed. Server hello done means only the authentication part and other things and the choice of algorithms is fixed. Now, the generation of the keys. Okay. So, the client responds with a client key exchange message, which may contain a pre-master secret, a public key, or depending upon the security requirements may be nothing. Not like pre-master secret, it was no, in Needham Schroeder basically the KDC was giving those keys, it was generating the session key between, no, you were using that session key, you were not using it to generate some more. Pre means, that means till now it is simply the starting point of generation of some common secret. Okay. So, you are as if providing say some information about generating a secret key, and that information may be, say, if you want to generate say 64-bit key for example, you can think that the pre-master secret may be 32-bit and generate the next 32-bit, or you can also think that I will give a 64-bit which will be say added or subtracted or some function on it to get a common master secret. But the algorithms should be known on both sides. You can generate pre-master secret like that using random number generator. I mean, otherwise how do you generate any number, right? And that is why if you make the numbers lengthy, then the chance of repetition is less, that is why. The client and the server use the random numbers and the pre-master secret to compute a common secret called the master secret. Okay. So, you see there also there were two random numbers exchanged and both of them know both. I mean, I have mentioned here one, I think the server also sends back some random number. I mean, it may be optional, but whatever. All others are derived from this master secret, and the client and server generated random values passed through the random functions. Okay. That means, now you have a master secret, but this is also not the actual key that you will be using. So, you see for the key generation also you have so many pre-steps, pre-design steps you can say. Firstly, the picking up some pre-master secret, firstly picking up random number from both sides, then client choosing some pre-master secret, then using all these three to generate some master secret. Remember one thing, that both sides will individually generate these. Have you heard about Diffie-Hellman? So, similar to that, so that both sides are able to generate the same number. No, I mean, of course, they will not be same, because these are generally as I have already told that the random number generators, you can get a pattern, but that is after so many usages that it will not even fit into the scheme. I mean, it is not problem that the same number will be, I do not think same number will be generated, and you are taking a very large lengthy. But the algorithm to generate the common master secret must be same on both sides. These 3 numbers are already with both sides. So, the function to be computed on these 3 numbers must be same on both sides, then only you get the same common master secret. Firstly, all other is derived from this master secret. That means, again another step, that pre master secret will now be replaced by this master secret, and those random numbers are already there. But if those random numbers are thought to be nonsense, that means you use them only one time, then you can again just exchange some other random numbers, replace one random number maybe. Okay. So, everything is passed through the pseudo random function again once again. The client sends change cipher spec notification, okay, because already the algorithms have been selected, and client finished message. After receiving the change cipher spec, server switches its record layer security state. That means, it also confirms that yes, these algorithms are final, and then sends the server finished message. So, the record protocol, though we have already discussed it, it secures the application data using the generated keys. So, it divides the outgoing messages into blocks, as I have told you. That means, the message may be very lengthy. So, the message has to be divided into blocks, reassembles the incoming messages, and reassembling is always part of responsibility of this TCP layer. Okay. And as I have told you, that compression decompression may be optional depending on the level of security you require. It can apply MAC on the outgoing messages, message authentication codes, and also verifies incoming messages using MAC. But remember that if you want to verify incoming messages, then you have to get the incoming message in clear along with the MAC version of the incoming message. Then only in the receiving side you compute again the MAC of the incoming message and compare it with received MAC and calculated MAC. If both are same, then only the receiver will accept the message. And message in clear means, you can always send in clear, because if anybody grabs the message, even if it changes a single bit, the hash that will be generated from this distorted message will never be equal to the original MAC or hash. Okay. So, the receiver in any case will get to know that something bad has happened. Then encryption decryption may be performed, because we have already chosen the algorithms. After handshaking and record protocols are completed, encrypted data is passed to the TCP layer. TCP layer means in the same layer it was working, it is now complete. So, the instead of plain and simple data, it is now encrypted data. Now, then it is handed over to the IPsec. This time we are going to discuss MIME and secure SMIME. So, what is MIME? It is basically multi-purpose internet mail extension. So, it was developed much earlier, and it allowed people to send pictures, sound, programs or general attachments instead of only plain text messages. Okay? That means, the attachments may be of any kind, not only text or textual attachment. But however, MIME had no security features, because as I have told you, maybe lack of awareness, or maybe people thought that nothing confidential would be sent like this over the network. So, people did not bother about it. but of course, since it was prone to some attack or maybe some untoward incidents happened. So, people thought about getting a secured version of this MIME, and this resulted in the S-MIME. So, it stands for Secure Multipurpose Internet Mail Extension. So, it is the security enhancement to the MIME, internet email format. And so, we may see the security enhancement portions. So, it provides all that is required of security, that means confidentiality. So, only the intended recipient is able to read the message. Authentication, the recipient is able to verify the sender, as we all know now, and integrity also, that means the recipient is able to verify that the message was not changed en route, that means during the transmission in the various links, hops and etcetera. So, these are the functionalities for security that S-MIME provides. So, the functions that it has, it therefore provides you with enveloped data. So, whenever this term envelope comes, it means that it is some, yes, some extension header is there, and therefore, it indicates how you have done whatever operations you have on your data. So, it consists of the encrypted content. So, what protocol do you have, do we generally have in our network architecture that you are supporting now?
We are using IPv4 and transitioning to IPv6.
Yes. So, do not you think S-MIME is also being adopted now?
Yes.
Yes.
In devices where IPv6 is
Yes, and by different mail servers also, okay, not only mail servers, but say Google servers, like that, because it is not only, it is not that it is an internet message exchange content. Okay. So, you may try to send it in any way you want, and obviously, it is enhanced. So, it will, the aim is to work with IPv6. And that is why I did not talk about the Open PGP or PGP, okay, that was more general, but I thought that you may know the latest in the market or other things, that is why. So, it has enveloped data, signed data. So, that means both that cryptography is used for confidentiality and authentication. Clear signed data, that means encoded digital signature, encoded. Okay. One is signed data, contains the digital signature, another is encoded within the body, and signed and enveloped data. So, both are there. Okay. That means encrypted as well as signed, the one that I showed you, that how you can put everything in an envelope and then sign it and send it, just like that. So, what algorithms it use? So, it has to create message digest to form the digital signature. I mean, not it has to create, I cannot say that, the way that S-MIME takes its functionalities implementation to be. Okay. So, it uses SH1, should support MD5, and maybe it will be extended later on also, right, because the algorithms will be changing and hence the names will be changing. But the basic concept that this particular type of message digest or this particular type of hash function is required, that will remain the same. Encrypt message digest to form the signature. So, that means at first you have the message digest, then you encrypt it for the signature purposes, then encrypt the session key for the transmission. Okay. And therefore, you see so many type of algorithms and schemes, not only algorithms, but some special schemes are also mentioned here. All these are supported by the S-MIME cryptographic system. So, the messages for the transmission will be encrypted with one time session key. Okay. So, what does this mean, one time session key? That means your communication session, the time that it will last, it will use that key, and if the session is broken, I mean you completed the session, for the next session some other session key will be generated. This is also for security purposes, the same key is not repeated. Okay. So, it may support the triple DES, may support AES, should support RC2, all these are several schemes and algorithm names. Okay. Then create a message authentication code. So, it must support the HMAC with secure hash algorithms. So, in total therefore, these are the algorithms for different stages that are used by S-MIME, and you see many of the algorithms are common for more than one stages. Of course, I mean what will you do with different algorithms at every stage? It will only increase the complexity. So, key generation will be using the RSA algorithm. So, I hope you already have idea about RSA and how the public private key pair is generated. Okay. Then the registration, a user's public key must be registered with a CA. We have already seen that in so many other different protocols. Okay. So, here also it is required that the public key should come from the certification authority, because otherwise nobody would believe. Then the certificate storage and retrieval, this is also very important, because you see I may be talking with many different types of say clients or users or whatever in the network, and many of them will definitely not have the same CA. So, how do the certificates, how will the certificates be stored and get in time, whether you will verify the signature of the certification authority all the time, or you depend upon the expiry date that is mentioned on the certificate, everything has a question mark on it. Okay. So, this is also really, I mean if you want to add security, it will be coming with an overhead, that is for sure, but obviously it will also, I mean give you more support, more robustness in your system. Your system may not crack with a simple attack or something like that. So, certificate storage and retrieval, that means access to a local list of certificates in order to verify the incoming signatures and use that public key, I mean retrieve the public key from the certificate for encrypting the outgoing messages. So, also this is somewhat different, that there are concepts of signed receipts. The receiver returns a signed receipt back to the sender to verify the message arrived. In general, we have seen only some acknowledgements back, right, some SEK 01 like that, very short, so that it does not cause any traffic overhead in the network. Security labels. So, that means there are some permissions, rights, priority or role of a message being sent, all these may be mentioned under different security labels. Secure mailing lists, sending to multiple recipients at once securely by using a public key for the entire list. We always build lists, is not it? You can mention it also, I mean not only group, but you can also have a list of your own, okay, where I mean you can divide the users in a category that you like, friends, family, like that, work, and in that way you can create a list. So, when you just like that you nowadays have a list in WhatsApp, right, school friends, college friends, best friends, like that. So, similarly here also you can have mailing list like that. User A wants to send message that only B can read. Of course, that is our aim, is not it? So, what will happen? The cipher text will be some, what is PKC? It is using public key for the encryption system, is not it? So, nothing but public key cryptography sort of thing, I mean some algorithm chosen from the list of algorithms, and the plain text will also be deciphered. And obviously, only B can decrypt the message and A does not have to send her the key, because it is B's private key paired with B's public key. And you know the rule that the public private key relationship should be such that it is computationally infeasible to generate the private key from the public key. So, for authentication, all of you know this, we have already discussed everything. So, you know how you can more or less as if get a signature of the sender. So, using the sender's private key, and therefore, at the receiving end it will be deciphered using the public key. I think one step is not being mentioned is that it may not be only plain text 1, it may again have this first stage. Understand, that means already encrypted first stage, then you sign, at the receiving end you first remove the signature and then remove the encryption with the private key of your own. So, it may not be always plain text 1, it may be some cipher text also, okay. No problem in that, I mean again it depends on the implementation. So, oh sorry, I think this is what it is mentioned over here. So, no problem, you have everything. So, you understand. So, we are going to the next. So, in this way both confidentiality and authentication can be maintained. Then hashing, a one way operation, I mean why and where these will be required, because it is hard to undo and it will result generally in a short message, as you have seen that our data was 1 2 3 4 and the hashed message was 10 10. So, it is called a message digest. So, the example I at least do not understand, do you understand? It is just an example that instead of such a big sentence you may have only this many number of characters. But there is a problem. What problem? How does B know that it is really A sending her the message? So, that is where the public key certificate comes in. We have already discussed it. So, you know that these are the, I mean some of the fields, most important fields of the certificates which will be required more frequently. There may be many other fields also which are not being mentioned, because according to X.509 there are so many fields and subfields, okay, and we are not discussing that, that is why. So, the public key certificate will contain the person's name, the person's public key, name of the trusted certifying authority and digital signature of the CA. So, these are must for the authentication of that particular person. So, certificate can be verified and X.509 is the most common format, as you all know. So, what does therefore S/MIME do? Everything is there, but in bits and pieces, right. Everybody is saying that if you do this you will achieve this, right. So, S/MIME puts all these techniques together to create a practical, efficient and reasonably secure email protocol. So, this protocol is targeted towards mails only. Okay. because you want to send attachment, different types of attachment, right. So, it is aimed towards email. Now, the thing is that you see we have said so many good adjectives, practical, efficient, reasonably secure, etc. So, that means even though these particular components existed be in bits and pieces, but how you combine them so that you really get this efficiency is a questionable thing, because you can combine these things in many different ways, right, according to maybe some particular policies. Okay. You can do compression also. You may say that no, I will not do compression, I will do compression after say generating the hash. Somebody may say no, after generating the encrypted entire text, entire attachment. So, there may be many different combinations of putting these pieces together. Important part is that means how really you stitch them together, which will actually offer you these functionalities. Okay. So, symmetric cipher that is used is RC2 or DDS. The asymmetric cipher, that means public key algorithm, is RSA, and hashing algorithms are these. So, all are well known algorithms, and not only well known, but tested algorithms. Okay. When they will break, that is also known, how they will break. So, everything is known beforehand, hence it is very easy to accept them, because you know for how long you are going to use this particular thing, because it is for a session only. Okay. So, it is short lived, right, and hence even if somebody grabs the key or tries to hacks into your account or something like that, the replay may be thwarted. So, for secrecy also you can use it. So, A's email program creates a random key, which is session key to be used in symmetric cipher. A's email program will encrypt the message with the symmetric cipher. A's email program will encrypt the session key with the public key, PKC, and the B's public key. Now, tell me, how will B know that particular random key that A's email program is going to use as a symmetric cipher? Because you see, A's email program will create a package of the encrypted message, encrypted session key, the X.509 certificate, names of the encryption algorithms, etc. I am telling in the first step, you see A's email program is creating a random session key, and that is symmetric. So, B should also have it. Only thing that is known to A is B's public key. So, using that weapon, A is taking all these steps, and in none of these steps we have mentioned that A is also sending the symmetric cipher to B, is not it? Directly we have not mentioned anywhere, but then why is A generating this symmetric cipher and session key? Obviously, only for confidentiality purposes, for security purposes. Now, go to the fourth step. A's email program creates a package, encrypted message. So, encrypted message means it will be encrypted with either with B's public key, or can it be encrypted with the generated session key, symmetric cipher key? No, you see there are two options already. Then next, encrypted session key. This encryption can only be with session key generated by A. So, A only knows what? B's public key. So, how will it encrypt the session key? Only by B's public key. So, 5.509 certificate of own and names of the encryption algorithms. So, how will B retrieve the encrypted session key? Yes, with its private key it first gets the session key, and then if A has really encrypted the message with the session key, then it will also get the message, is not it? Because there only comes the effectiveness of the usage of the session key, because this encrypted session key cannot be decrypted by anybody other than B. That is why I was telling that various things are there, how you put them together is of great importance. You can put them otherwise also, okay. But here as if that if you, how will you use this dynamic key, because it will change from session to session. So, even if somebody grabs this mail in the middle, it will be of no use, that is why. So, again for authentication, how will it do? Email program uses hash function to create the message digest. Remember that this hash function is the same that B will also use, because I mean it will again go in the package which hash function has been used. A's email program encrypts the message digest with PKC and own private key. A's email program creates a package, the original message. Here it is for authentication only, I mean we have not combined both till now. That was for secrecy, confidentiality, and this is for authentication. So, plain text message, original message, encrypted message digest, the certificate and the names of the encryption algorithm. So, A's email program sends the package to B, and therefore, B's email program after receiving the message firstly verifies A, gets the public key of A from the certificate sent by A. So, from A's certificate B will get A's public key. Okay. So, here it is mentioned B's email program therefore use A's public key to decrypt the message digest, encrypts the message digest with private key. So, only it will be decrypted with public key of A. So, here it is decrypted. B's email program independently computes the message digest, as I have told you, since it is a one way function. So, B has to, I mean the receiver has to again calculate it, okay, using the same hash function, and B's email program then compares. We have already seen these stages before. So, now both together, okay, because that is what we want. We want confidentiality as well as origin integrity. So, message is authenticated first. So, this is the first step. Then the authenticated package is made secret. That means, firstly it is authenticated by these steps 1 till 10, I mean not 10, I mean only authentication, it will then be put, then it is given these cryptographic algorithms for this symmetric cipher was generated, and the symmetric cipher is acting as the session key and encrypts the session key with B's public key. So, that only B can find out the encrypted session key and the message. So, this is the second step here. So, secret message is sent to recipient and receiver first. Now, you see receiver uses the private key to decrypt the session key. Okay. Receiver uses session key to decrypt rest of the secret package that was there. So, thus yielding the authenticated message. So, this is how both will be assured, okay. And also you can thwart some of the attacks. I mean, it may not be possible to exclude some attack, because sometime we may not even end the session, though we have completed our say talks and exchange of emails, we may have forgotten to end our sessions. So, the session key may still be active if it does not have any elapsed timeout. Okay. So, all these problems are always there. So, there are 5 message header fields in the MIME: the version, the content type, the content transfer encoding, ID and the description. I do not think this will be of much interest to us, because we can never. So, these are the type of the contents. So, you see everything is there: image, video, audio, simple text, and content transfer encoding is 2 types: quoted printable or base 64 transfer encoding. So, basically therefore, you see that SMIME provides you with both secrecy, that means imparting confidentiality, and origin authentication, origin integrity in the messages that you receive, and it is aimed towards mail exchanges. So, these are some of the references. Okay. You can go through if you want.